subscribe to our channel Mechanical Guru and click the bell icon to get the notifications regarding the new videos. You can also find me on Facebook and Instagram.
Hello students, in this video I would like to introduce you with a new subject, strength of materials. When I talk about this subject, it is clear from the name that this subject deals with the study of materials. Materials that we use in our engineering applications. Now, this is strength of materials. That means, what would be the load carrying capacity of a certain material? By this subject, we can calculate load carrying capacities of different materials. The knowledge of this subject is very important for designing of different components like ropes, trusses, nuts, bolts, engines, frames, trusses, power transmission system, etc. This subject is also known by another name, SOM. So, for a design engineer, he should have very deep knowledge of this subject. He should have all the concepts clear regarding this subject. Okay. When I talk about this subject, the first thing that comes into my mind is stress. What is stress? What will be the definition of stress? Stress may be defined as internal resistance of a body or a component to external loads. So what is this internal resistance and what is this external load? I would like to explain these two concepts to you with the help of some examples. Suppose we are having a rectangular bar on which we apply some load on it. Suppose this load is P. If we apply this load on it, what will happen? It will try to deform it. There will be some deformation like this. Okay, the load will apply on this body like this. After applying this load on this object, on this body, on this component, what will happen? A restoring force will generate in an opposite direction of it, so that the deformation will not occur on this subject. The main aim of these restoring forces are to regain its original shape, to regain the component's original shape. To reduce that deformation, there is generated an internal resistance or the restoring forces. These restoring forces what we call the internal resistance. These restoring forces act in opposite direction to external loads, and the main aim of these restoring forces is to reduce this deformation. So, I can explain this stress as it is the internal resistance of a body against deformation. Okay, so mathematically, this stress is defined as the ratio of load per unit area. This stress is noted by letter sigma. It is equal to ratio of load here is P, to the area on which, area of cross section on which this external load is applied. So here is the area. Now the question is, what will be the unit of this stress? If we will see this, that this load is measured in newtons and this area is in mm. But here is mm square. How this mm square will come? As we know that area is equal to, for a rectangular section, area will be equal to length into width. That means length this into width this. Length is measured in mm. So here L is mm and width is also measured in mm. Also we have this mm. So it will become mm square. That's why we are taking here this area in mm squares. And this Newton per mm square is the unit of stress in SI system. And in MKS system, this stress is measured in kgf, kilogram force per meter square. Okay, this is the unit of stress in MKS system. Okay, now the question is, how can we convert the units of this stress? Suppose we have 1 kilopascal. So this 1 kilopascal is equal to 10 raised power 3 Pascal. This Pascal is equal to 10 raised power 3. Pascal is equal to Newton per meter square. Okay, so to convert this meter into mm's, we will get 10 raised power 3 Newton per 10 raised power 3 mm square, because 10 raised power 3 mm is equal to 1 meter. Okay, so we will multiply this meter with 10 raised power 3. It will get converted into mm's. So from here, 10 raised power 3 Newton per 10 raised power 6 mm square. This 10 raised power 3 and 10 raised power 3 will get cancelled. It will become 10 raised power minus 3 Newton per mm square. So 1 kilopascal is equal to 10 raised power minus 3 Newton per mm square. Here is the relation between kilopascal and Newton mm. I will take an example. 50 kilopascal is equal to 50 into 10 raised power minus 3 Newton per mm square. Now, if we have 1 megapascal, 1 megapascal is equal to 1 into 10 raised power 6 Pascal. It will become 10 raised power 6 Pascal is equal to Newton per meter square. Or it will become 10 raised power 6 Newton per 10 raised power 3 mm whole square. Now, further, it will become 10 raised power 6 Newton per 10 raised power 6 mm square. This 10 raised power and 10 raised power 6 will get cancelled. We will get 1 megapascal is equal to 1 Newton per mm square. This is the relation. Now, again, if we have 1 gigapascal, 1 gigapascal is equal to 10 raised power 9 Newton per meter square, as 1 Pascal is equal to Newton per meter square. So, here we become 10 raised power 9 Newton per 10 raised power 3 mm square. Okay, so it will become 10 raised power 9 Newton per 10 raised power 6 mm square. This 10 raised power 6 and 10 raised power 6 will get cancelled out, and we will get 10 raised power 3 Newton per mm square. Okay, so 1 gigapascal is equal to 10 raised power 3 Newton per mm square. If we have 70 gigapascal, it will become 70 into 10 raised power 3 Newton per mm square. So this is the relation between gigapascal and Newton. In the next video, I would like to introduce you types of stress, strain, types of strain, and the relation between stress and strain known by Hooke's law.